Welcome to my vlog on big data and cybersecurity. My name is lipyeow-lim. I'm a computer scientist, an educator, and a software engineer. Today, I'm going to talk about multi-cloud IoC search using Mach 5. Mach 5 is a Databricks partner that provides full-text search capabilities on top of Databricks Delta Lake. Now, I believe that IoC search and search capabilities will be important to SOC and incident responders, given all the tools that we have today. Even if you can prefetch a lot of the context, a lot of the assets, a lot of the threat intel that's needed by the SOC analysts when they are triaging alert, or by the threat hunters when they hunt for a threat, or by incident responders when they investigate incident, there will always be cases where the analysts will need fast and quick searches on IOCs that they discover on the fly as they're investigating an alert or an incident. So in the scenario that I'm going to show you today, we have log data coming into AWS, we have log data coming into Azure, and we are not going to consolidate the data into one location. Instead, we're going to set up a Databricks workspace in AWS and a Databricks workspace in Azure. We're going to ingest all the log data in AWS into the Databricks workspace in AWS. We're going to ingest all the log data from Azure into the Databricks workspace in Azure. And what Mach 5 does is that Mach 5 provides an indexing job that runs within Databricks Compute. And that indexing job will index all the Delta Lake data that you want it to index, and you will write those indexes to cloud storage. And Mach 5 also then provides a Mach 5 search component, or an app or server, however you want to think of it. But Mach 5 search basically serves out through the opensearch API or elasticsearch API. So it will receive a query via the opensearch API, and it will then run that query against the Mach 5 indexes in cloud storage, and then serve the results back to the caller of that API. What you can do then is that you can use any UI that speaks OpenSearch API or Elasticsearch API of your choice. I will be using OpenSearch dashboards, but you can use Kibana as well. And these UIs can be hosted on any cloud or even on-prem if you choose. So let's dive right in. So this is what I'm showing you here is the AWS workspace, and I'll kind of dive into the catalog just to show you the data. And the data I'm going to be using, it's going to be here. It's going to be HTTP logs from Zeek. And you can see it's fairly standard HTTP logs schema. And there's probably like 2 million records in here. And we're going to have the same setup in Azure, but with a different kind of security logs. I'll pop over to the workflows tab, and you can see there's a bunch of different workflow jobs. I'll pop into this one. So this one is used to run the indexing. And if I look at tasks, it's just a single task that runs the Mach 5 Databricks indexer job, main class, using a particular cluster. And you can see that the parameters applied to it is that it's going to index this particular table that I showed you earlier. Now let's pop over to the OpenSearch dashboards. So this is the OpenSearch dashboard UI that I will be using. And as you can see, I'm going to go over to the Discover part, and and by default, I have 3 index patterns defined. This is the Azure cluster index pattern. So this just queries the data in the Azure part of of my system. Basically, it's the part that, let me go back to my diagram. It's querying this portion, the blue portion of my data. And you can see that I have data that's from 2021, and then a little two counts of data in 2022. I'll pop over to the AWS one, and you now can see that. So give it a second. You now can see that I have like 2 million records in the 2012 timeframe, but nothing else. And now I'll go to the index pattern that contains both of these clusters. It's this one. And now this is actually now searching over both clusters. So it's a federated IoC search, if you will, a federated search interface. Again, all the data in 2012 and the data in 2021 and 2022 are here. And now with this, you can do a bunch of IoC search. For example, I can start with, maybe I'll start with typo squatting, right? PHP myadmin. What this does is that I'm going to look for domain names that looks like PHP myadmin with an edit distance of 2, meaning possibly any 2 character changes. And you see that it brought back data from 2012. There were like 16,000 hits. And if I then zoom into the data, you see that there's a underscore index. This specifies which index it came from. So this came from the AWS cluster. And let's zoom down and let's see. So this is probably where the match happened. And it's an exact match, so probably it's not too interesting. Oh, by the way, I am using the Lucene language, and let's get rid of the exact matches. So from 60,000 hits, I went down to 97 hits, which is fantastic. We can zoom in on the details. Still gave me this one, but maybe what I'll do is I'll add a regular expression. Maybe is this the one? Yes. Let's do this one and refresh. And this brought it down to 70 hits, and I should have slightly better data now. Still got this one, but there's probably others that's more interesting. Anyway, so with this, again, remember what's happening behind the scenes, that this query is getting pushed to the Mark V search in AWS, and then it's also pushed to the Mark V search in Azure, and Mark V search is searching the indexes in the cloud storage in both of these environments and then bringing the results back. The original data is not in Mark V. The original data sits in Delta Lake, in Databricks, in AWS, and in Azure. Now let's try another search. Let's try a IP address. And let's try this IP address. Let's hit return. Again, pretty snappy response. We got 14,000 hits. We have some hits in the 2012 data set, and we have just one hit in 2021, right? And of course, you can actually zoom in. You can actually zoom in on the 21 by just clicking on this, and it will bring back that one row with the match in this case. Now, next, I'm going to show you that with the opensearch API, you can also use that in notebooks. And it's actually a very simple thing to do. You just use the opensearch PY, which is the opensearch client for Python, and you can just specify the Mark V search instance as your host, and you can then write your queries as a JSON that you then send over to the Mark V client, and then you can bring the results back within your Databricks notebooks. Now, it's you can also then package this into a UDF that you can then call in SQL within Databricks, either within the notebook or within the DB SQL. And so this is how you would do IoC search across multiple cloud, and you could see that the response times is pretty snappy. You definitely have a good interactive experience, and so this would be fantastic for SOC analysts and incident responders. Thank you very much. See you next time.